We don't need to unwrap and texture faces that are not going to be seen. Although there are not many, there are some we can remove before unwrapping. Open Bench01.blend if it is not already open. Hide the end meshes and select the board's mesh. Switch to front view, and in edit mode and face selection mode, box select and delete the end faces. Switch to back view, and in edit mode and face selection mode, box select and delete the end faces. Delete bottom faces that you think will not be seen. Select the ends and delete the bottom faces. One can spend a lot of time unwrapping a model so that the seams don't show when texturing. But we are not going to be viewing this model on a 40-foot theater screen. Moreover, the texture to be applied to the ends will be rather plain and not viewed particularly close up. However, we do want to ensure that the boards are all orientated in the same direction to facilitate applying a wood texture with wood grain. We also want to make sure that the boards occupy a significant portion of the UV map, as they will have a wood grain texture detail. Switch to the UV editing workspace. In the UV editing window, create a UV map. Select the image menu, then New, name the image UV map, and select OK. In Object Mode, in the Outline window, select the board's mesh. Switch to Edit Mode and Face Selection Mode, and select All. Keyboard shortcut the A key. Unwrap using Smart UV Project. Keyboard shortcut the U key, then select Smart UV Project. Set the island margin to 0.006 and select OK. In the UV editing window, you will see that the Unwrap has the boards all orientated in the same direction and occupying half of the UV space. Great. Now in Object Mode, hide the board mesh. and select the two end meshes. Make sure all of the faces are visible. Keyboard shortcut Alt plus the H key. Select all and unwrap using Smart UV Project. Keyboard shortcut the U key, then select Smart UV Project, then OK. In the UV editing window, box select all of the end islands and move them above the UV map tile. In object mode, select all three meshes. Switch to edit mode and select all. In the UV editing window, open the Properties panel and select the UV Packmaster 3 tab. With the end islands selected, select Pack to Others. Save your UV map. Keyboard shortcut the File menu, then select Save As, then select Save as Image. For the ends, I have chosen blistered paint PBR 0116 from textures.com. Download the 1K 1024 by 1024 pixels, albedo green, normal, and roughness. For the boards, I have chosen rough old wood PBR 0044 from textures.com. Download the 1K 1024 by 1024 pixels, albedo, normal, and roughness. We can now apply the PBR material texture sets to our model using PBR Painter. Let's combine the two end meshes as we are going to apply the same material to each. In object mode, select the end left mesh and the end right mesh and join. Keyboard shortcut Control plus the J key. Rename the meshes ends. Switch to the PBR Painter workspace and drag down the bottom border of the 3D editor window to enlarge. With the ends mesh selected, add a new material and name it ends. Complete the addition by selecting in the Properties window on the right, Set up material for PBR Painter, and select OK. Select the new layer icon and name the new layer Blistered Paint. Under Filled Painted, keep filled and select OK. Select the Import Material icon. Locate and load the Blistered Paint PBR 0116 textures, albedo, normal, and roughness. Select Refresh Material to see the PBR material texture set on your model. The blisters are a little large. Not that anyone's going to see them, but let's reduce their size anyway. Scroll down and open the Texture Map chevron. Set the scale XY to 40 and 40. I think the green paint is a little bright, so let's tone it down by adding a paint layer. Select the new layer icon and name the new layer black. Under Filled Painted, keep Filled and select OK. With the color icon selected and the color type constant, select the color swatch and drag down the slider on the right to black. Select the red refresh material. Reduce the opacity to 0.25, or where you would like it to be. Zero opacity adds no black, and 1 opacity is completely black. In the Properties window on the left, select the board's mesh. Add a new material and name it Boards. Complete the addition by selecting in the Properties window on the right, Set up material for PBR Painter, and select OK. Select the new layer icon and name the new layer Rough Old Wood. Under Filled Painted, keep Filled and select OK. Select the Import Material icon. Locate and load Rough Old Wood PBR 0044 textures, albedo, normal, and roughness. Select Refresh Material to see the material texture set on your model. The wood grain is running in the wrong direction, so let's rotate it in the texture mapping. Scroll down to the Texture Map chevron and set the rotation to 90 degrees. Before we save the Blender file, I noticed a couple of errors in the model. I have no idea when or how they occurred. Often when this happens, you do not have to go back to your last save file. Rather, you can try and fix the error. Let's try to fix them before moving on. Hide the ends mesh and select the boards mesh. Switch to the Layout workspace and Solid mode. With the boards mesh selected and in Edit mode and Edge Selection mode, select the two top edges and fill in the faces. Switch to Face Selection mode, and with the two faces selected, switch to the UV Editing workspace and unwrap. Keyboard shortcut the U key, then select Smart UV Project. Set the island margin to 0.006 and select OK. In the 3D Editor window, select all of the board's mesh. Keyboard shortcut the A key. In the UV Editing window, switch to the Island Selection mode. Select the two new faces and scale down. Keyboard shortcut the S key and drag. And position them with the other board islands. Keyboard shortcut the G key and drag. Save your work select the textures into your Blender file. Keyboard shortcut, select the File menu, then select External Data, then select Pack Resources. The 6 texture files will be packed with your Blender file. Save your Blender file as bench03.blend. We are now ready to bake out our texture files for export from Blender. Let's take a minute to review what it is we need to do. We need to create 3 files. The first is a diffuse file. It is also sometimes referred to as an albedo file or a base color file. This file contains the information on the color of the surfaces of our model. Here we want to include the color information from both the ends and the boards. The second file we need is a normal file. This file contains the information on the surface bumpiness or smoothness. Notice how much bumpier the surfaces of the boards are compared to the ends. The third file we need is the parameters file. I've outlined the file in yellow as it appears transparent. That is, it looks like it does not contain any information, which is not true. The parameters file contains 4 types of information about the surface, packed into the 4 individual channels that make up an image file: red, green, blue, and alpha. We can see this if we open the file in GIMP, where we can view each of the channels individually. In GIMP, the file again appears transparent. But if we look at each of the channels individually, we will see that the red channel containing the emission information, that is, whether the surface emits light or not, is black. Black means that the surface does not emit any light, while white means that the surface emits light. If this was the surface of a light bulb, we would need the red channel to be white. The green channel contains the roughness information, that is, whether the surface is matte or shiny. The blue channel contains the ambient occlusion information, that is, whether there are shadows that hide surface detail. The alpha channel contains information on whether the surface is metal or not. If the channel is white, then the surface is metallic. If the channel is black, then the surface is non-metallic. The channel can also be transparent, as it is here, which also represents non-metallic. The parameters file is the trickiest to create, as the combination of red equals emission, green equals roughness, blue equals ambient occlusion, and alpha equals metallic is unique to Trainz. In Blender, the 3 texture files are linked to the model's structural data by a node tree that can be viewed in the shading workspace. This node tree has 6 nodes. Nodes are containers that hold information that is passed on to other nodes. The sequence is from left to right. Nodes are connected by threads known as noodles. One of the advantages of using PBR Painter to texture models is that one has to know very little about nodes and node trees. In fact, the node tree you are looking at is the only one you will need to know and understand, and can be generated automatically by PBR Painter. On the left side are 3 image nodes, which is where you add, from top to bottom, the diffuse, parameters, and normal information. As the parameters and normal files contain non-color information, you also need to change the color space to non-color. This information is passed to the BSDF principled shader node through noodles that connect to the inputs on the left side of the BSDF principled shader node. The BSDF principled shader node has several inputs, but we will use only 3 to feed in the diffuse, parameters, and normal information. The diffuse information is fed into the base color input. The parameters information is fed into the roughness input. And the normal information is fed into the normal input. The normal information requires one more node, the normal map node, which is positioned between the image node and the BSDF principled shader node. The information compiled by the BSDF principled shader node is fed into the material output node. With PBR Painter, baking is carried out in 6 steps. In order to follow our progress, change the Properties window on the left to an outline window. That will show the baking texture files as we create them. Select the mode icon, then select Blender File. Expand the image chevron. You will see the UV map we created and saved, and the 6 texture files we imported from textures.com. The first thing we need to do is to combine all of the meshes that were laid out on our UV map. In the top outline window on the left, select the Ends mesh and the Boards mesh, and with the mouse cursor hovered over the 3D Editor window, join. Keyboard shortcut Control plus the J key. Rename the mesh Bench. The next thing that we need to do is to combine the textures associated with the meshes. With the bench mesh selected, in the Properties window on the right, select the Baking button. Select Merge. Then select Merge all materials on model to a single material. Note in the image file list that 3 new files have been added. Bench Base Color 4K Merged, Bench Normal 4K Merged, and Bench Roughness 4K Merged. If you switch back to Layer mode, you will see that we now have only one texture layer, named New Layer. In step 3, we create the diffuse and normal files. With the bench mesh selected, in the Properties window on the right, select the baking button. Set the resolution to 1K and the margin to 6 pixels. Select Save Textures Externally and choose the location to store the files. I have created a folder where the Blender file is saved, named Textures. Under Format, select PNG. Under Channel Selection, select Manual. Check Base Color, check Normal, then select Bake and OK. Open your Textures folder and change the file names. For Trainz, the file names must end in Diffuse and Normal, not 1K. In step 4, we channel pack the emission, roughness, ambient occlusion, and metallic information. PBR Painter 2.3.5 appears to have a bug that requires packing channels using OpenEXR format. The OpenEXR file can then be converted to PNG using GIMP. Change the format from PNG to OpenEXR. Check Channel Packing. Select Add Channel Packed Image and OK. Check Pack Individual RGB Channels. Set red equals none. Green equals roughness. Blue equals ambient occlusion. And alpha equals metallic. Select Bake and OK. Open GIMP and import the bench channel packed image 1k.exr file. Select Export As and name the file parameters. Select File Type by extension and select PNG. Select Export. In the pop-up window, check Save Color Value from Transparent Pixels and select 16 BPC RGBA. Select Export. Close GIMP. PBR Painter can create the node tree we need by creating what is called an exportable material. We need only indicate which principled BSDF shader node inputs we are going to use, that is, base color, roughness, and normal. Uncheck Channel Packing. Uncheck Save Textures Externally. Select Base Color, Roughness, and Normal. Check Create Exportable Material. Select Bake and OK. Under Materials, select the exportable material and change the name to material.m.pbr metal. This is the name we need for Trainz. The final step is to feed in the information in the newly created diffuse, normal, and parameter texture files into the node tree. With the material.m.pbr metal material selected, switch to the shader workspace. Swap out the textures in the image nodes. Remove the existing texture in the top image node by selecting the X. Select Open and locate and load the diffuse.png file. Remove the existing texture in the middle image node by selecting the X. Select Open and locate and load the parameters.png file. Change the color space to non-color. Remove the existing texture in the bottom image node by selecting the X. Select Open and locate and load the normal.png file. Change the color space to non-color. Save your work. Pack the textures into your Blender file. Keyboard shortcut select the File menu, then select External Data, then select Pack Resources. Save your Blender file as bench04.blend.